Hi guys, today we are going to learn about 3.4 composition of transformations, and you guys will be able to draw these. When a transformation is applied to a figure and then another transformation is applied to its image, the result is called a composition of transformations. So we have a glide reflection as one type of composition of transformations. A glide reflection is the composition of a translation followed by reflection and in line parallel to the translation factor. So if you think about stepping, you translate your foot forward and then it reflects. Really, it's your other foot, but it's like a reflection across. So example 1, we have a glide reflection. Quadrilateral BGTS has these vertices. We have to do two different things. You always do them in order. So it's image after a translation along this and then a reflection. So we have to do the translation first. So for that, we are going to be adding this vector to each of these points. So B prime, we're going to add 5 to x and 0 to y. G prime, same thing. Oh, I messed up here. Should have added 5. That's my bad. Fix that. So if you look here, my vector is included in each of these coordinates. So I can go ahead and simplify. B prime is 2, 4. G prime is 4, 3. T prime is 4, 1. And S prime is 1, 2. You can also just count these over, so we go over 5 up 0. So this is B prime. This is G prime. This is T prime. This is S prime. That is our first step. A couple days ago we would have been done there, but now we have to also reflect across the x-axis. This, guys, is right here. Remember, reflecting can just be counted pretty easy, so like T prime is 1 away from the reflection line, so you go 1 more. That's going to be T double prime. So it's not confusing. Anytime you have another thing that you add on to the translations, you add another prime. G prime is 3 away, so we go 3. It's G double prime. B is 1, 2, 3, 4, so we go 1, 2, 3, 4. B double prime, and S is 2, so we have S double prime. And yes, I do need to write down what these are. So B double prime, if I just look at my graph, is 2, negative 4. G double prime is 4, negative 3. T double prime is 4, negative 1. And S double prime is 1, negative 2. So when we take your test here soon, you're going to have to include both sets of points, single and double primes, as well as both on the graph. You can pause if you need to write that down. I'm going to keep going. For this next one, it only asks me, even though it gives me a lot of information, for L double prime. So I'm just going to look at L. I have a vector that I am translating along, so I'm going to add 3 to the x and add 1 to the y. That gives me 6, 1. And then I am rotating 180. You might have to go back and review from yesterday, but that just changes the signs of x and y. Okay, and since it only asks for the double prime value, that's all we have to write down. Once again, pause me if you need to write this down. And if you're ready, flip the paper and try the U-try. All right, I'm going to go ahead and go for it. Hopefully you paused, took a couple minutes to go through this. we have to plot our original, so r is 1, -1. S is 4, -2. T is 3, -4. U is 1, -3. Okay, from here, do it in order. We have to translate first, and then you have to reflect across the x-axis. So, translation. I'm going to go ahead and do the math here. So we have r prime will be 1, -4, because we're subtracting -4 to the x's and adding 1 to the y's. S prime will be 4 - 4, comma, -2 + 1. T prime is 3 - 4, and -4 + 1, and u prime is 1 - 4, -3 + 1. Notice on each of these my vector is in each coordinate. That's important. Okay, simplify these. R prime is -3, 0. S prime is 0, -1. T prime is -1, -3. U prime is -3, -2. So I'm going to graph these. R prime is here. S prime is here. T prime, -1, -3. And U prime, -3, -2. All right, then we have to reflect across the x-axis. So I'm going to go ahead and just do that right now. R prime and R double prime are the same because it is on the line of reflection. S double prime is 1 away because S prime is 1 away. T double prime is 3 away from the line of reflection, and U double prime is 2 away. So you can go ahead and draw these in, and that is your final translated shape. I do need to write these out. Reminder, double prime just means it's your second thing, so our points are -3, 0, 0, 1, -1, 3, -3, 2. All right, pause me again if you haven't tried 2 yet. I'm going to jump right in. For this one, we're plotting triangle, points T, U, V, so 2, -1 is T, 5, -2 is U, and 3, -4 is V. Once again, we are translating and then rotating. So, translation, I'm going to do the math. T prime will be 2 - 1, -1 + 5, because we are subtracting 1 from x's and adding 5 to y's. U prime, 5 - 1, -2 + 5. V prime, 3 - 1, -4 + 5. So we get 1, 4, 4, 3. Oops, that looks weird. Should be a U prime. And then V prime is 2, 1. We do need to graph that. So we have 1, 4 for T, 4 for U, and V. Reminder, these are all primes. And then we have to rotate 180. Once again, you can go back to your notes about it. When you're rotating 180, this just changes the sign of each of these. So T double prime, U double prime, and V double prime get their signs changed. So we have -1, 1, 2, 3, 4, T double prime. So that's T double prime. And then we have 1, 2, 3, 4, 1, 2, 3, U double prime, and then V, -2, -1, V double prime. So that is my final translated shape. I need to include my values of the single prime, the double prime, as well as the figures, all three of them really. Now, once you guys finish this, I would like you to flip your page and work on the worksheet. Once again, there's no deltas for this section. I do want to point out to you guys that on my key, I only include the image for the double prime because I didn't want it to look super crazy on your paper and be confusing. So as long as your double prime matches up, the rest of your steps should be fine. I do have the coordinates of all of them though. So go ahead, work through this, try them out, check your work on Classroom, and I'll see you guys soon. Bye.